Long before humans walked the earth, before cities rose and empires fell, before the first words were spoken or the first fires were lit, the world belonged to creatures so enormous, so strange, so unlike anything alive today that they seem almost mythical. For over 160 million years, dinosaurs ruled the planet, evolving into thousands of species, adapting to every environment from polar forests to scorching deserts. Tonight, we're going to travel back through deep time, back before history, before humanity, to when the Earth was young and life took forms we can barely imagine. In the dry riverbeds of what is now Texas, there are footprints preserved in stone. They're enormous, three-toed tracks over a meter long, pressed deep into what was once mud, but is now solid rock. These are the footprints of Acrocanthosaurus, a massive predatory dinosaur that lived 110 million years ago during the Cretaceous period. But the remarkable thing isn't just that the footprints exist, it's what they show. In one famous trackway, you can see the prints of multiple Acrocanthosaurus walking together, their strides matching, their paths parallel. And alongside them, smaller prints, young ones, walking with the adults. This is evidence of something we couldn't have known from bones alone. These massive predators traveled in groups, possibly family groups, moving together across the ancient landscape. Following the trackway further, you find another set of prints crossing the same area. These are different. Round, elephantine prints in sets of 4, each one enormous. Sauropod tracks, made by one of the giant long-necked herbivores that are among the largest animals to ever walk on land. The sauropod was moving quickly, its prints spaced far apart, indicating a running gait. And then the tracks converge. The theropod prints turn, following the sauropod. The sauropod's pace increases. You're seeing a hunt preserved in stone, a predator pursuing prey 110 million years ago. The drama frozen in rock for us to read like a story. We don't know how it ended. The tracks disappear where the ancient mudflat ended. But for a brief moment, frozen in time, we can see these animals as they lived. Not as museum skeletons, but as living, breathing, moving creatures with behaviors and social structures and the daily struggle to survive. Footprints tell us things bones can't. They show us how dinosaurs moved, how fast they could run, whether they traveled alone or in groups, how they interacted with each other and their environment. A skeleton tells us what a dinosaur looked like. Footprints tell us how it lived. The world that dinosaur walked through is almost unimaginable to us now. The continents were in different positions. North America and Europe were still connected. South America and Africa were just beginning to separate. The climate was warmer, with no ice caps at the poles. Sea levels were higher, creating shallow seas across what is now dry land. And everywhere, life was abundant but utterly alien. The plants were different. No grass yet, no flowering plants in the early part of the dinosaur age. Instead, ferns, cycads, conifers, and other ancient plant groups dominated. The insects were sometimes enormous. Dragonflies with wingspans of over 2 feet, beetles the size of rats. And in the skies, pterosaurs soared. Not dinosaurs themselves, but close relatives, ranging from sparrow-sized to absolutely gigantic, with wingspans exceeding that of small planes. Standing in those Texas riverbeds today, looking at footprints in stone, you're seeing evidence of a world that existed for so long that the entire span of human history would be just a blink in comparison. Dinosaurs ruled for 160 million years. Humans in our modern form have existed for maybe 300,000 years. If dinosaur history were a 24-hour day, all of human civilization would be the last few seconds before midnight. The footprints remain, preserved because the conditions were exactly right. Mud of the right consistency, quickly buried before erosion destroyed them, hardened into rock over millions of years, and then exposed again by erosion in just the right way to be visible from the surface. It's a series of unlikely events that had to align perfectly. For every footprint we find, millions must have been made and lost, erased by time and geology. But the ones that remain are windows into the past, showing us moments from prehistoric life. A predator hunting, a herd of longnecks migrating, a small dinosaur darting away from danger. These weren't fossils yet. They were living animals, going about their lives, not knowing that their footsteps would be preserved for eons, that creatures unimaginably different would one day find those prints and marvel at them. Imagine being that Acrocanthosaurus, walking across the mudflat with your family group, tracking a sauropod. The sun is hot, the air is humid. Insects buzz around. Somewhere, a pterosaur cries, out overhead. You move with purpose, following the scent or sight of prey, your massive feet sinking into the soft ground with each step, leaving impressions that will outlast you by millions upon millions of years. In the vast expanses of Patagonia, in the Badlands of Argentina, paleontologists have found some of the largest creatures to ever walk the earth. These are the titanosaurs, massive, long-necked, long-tailed herbivores that make even the famous Brachiosaurus seem modest by comparison. Argentinosaurus is known from fragmentary remains, but those fragments are massive. A single vertebra is taller than a person. The thigh bone is enormous, built to support incredible weight. Estimates of its size vary, but conservative calculations suggest it weighed around 70 tons, as much as a dozen elephants. More speculative estimates push it to 100 tons or more. It was possibly the largest land animal that has ever existed. But Argentinosaurus wasn't alone. Patagonia has yielded multiple giant titanosaurs, Portosaurus, Patagotitan, Dreadnoughtus, each one enormous, each one pushing the limits of how large a land animal can become. These weren't anomalies. For millions of years during the Cretaceous period, these giants dominated the southern continents. How did they get so large? The answer involves multiple factors. Their body plan was extraordinarily efficient. The long neck allowed them to browse across a wide area without moving their massive bodies. Their digestive systems were likely highly efficient at processing plant material, possibly with the help of bacteria in gut chambers, similar to how modern cows digest. They had air sacs in their bones and bodies, similar to modern birds, making their skeletons lighter than they would otherwise be. But perhaps most importantly, they could grow continuously throughout their lives. Unlike mammals, which reach adult size and stop growing, these dinosaurs never truly stopped. As long as they survived, they kept getting bigger. The truly gigantic individuals were probably very old, having survived decades or even centuries of predators, disease, and environmental challenges. Living as a giant titanosaur presented unique challenges. The amount of food required was enormous. Estimates suggest they needed to consume hundreds of kilograms of plant material daily. They likely spent most of their waking hours eating, moving slowly through forests and plains, stripping vegetation with their peg-like teeth, swallowing it whole to be processed in their huge digestive systems. They faced predators too. In Argentina, alongside the giant sauropods, lived Giganotosaurus, one of the largest predatory dinosaurs, rivaling Tyrannosaurus rex in size. A full-grown titanosaur might be too large for even Giganotosaurus to tackle, but young ones, sick ones, or isolated individuals would be vulnerable. The fossil record shows bite marks from large theropods on sauropod bones, evidence of predation or scavenging. Reproduction must have been a challenge at that size. They laid eggs, no live birth for creatures this large. But the eggs, while large by our standards, were modest relative to the adult size. A baby titanosaur hatching from an egg might weigh a few kilograms. An adult weighed tens of thousands of kilograms. The growth required was astronomical. They had to grow from puppy-sized hatchlings to mountain-sized adults. and somehow survive all the predators and hazards along the way. Nesting sites have been found where multiple titanosaurs laid eggs in the same area, suggesting they had specific breeding grounds they returned to. The eggs were laid in clutches, buried in vegetation or soil, and probably left to incubate on their own. The parents didn't sit on them, their weight would crush the eggs, and whether they provided any care after hatching is unknown. Some evidence suggests young titanosaurs had different proportions than adults, with relatively longer legs, suggesting they were more mobile and possibly able to follow adults. But much remains speculation. Walking beneath a titanosaur must have been an awe-inspiring experience. Their necks extended 10 meters or more into the air. Their tails, equally long, counterbalanced that massive neck. Their legs were like pillars, each footstep shaking the ground. The sound alone, the breathing of something that large, the rumbling of its digestive system, the cracking of vegetation as it fed, would be overwhelming. But they weren't monsters. They were herbivores, gentle giants who spent their lives peacefully browsing, living in herds for protection, raising young, migrating across vast landscapes following seasonal vegetation. They were successful for millions of years, spreading across South America and eventually to other continents, dominating their ecosystems through sheer size. Their fossils today are fragmentary, but impressive. Complete skeletons are rare because of their size. The bones are so massive that they're difficult for rivers or mud to bury quickly enough to preserve them. Most known specimens are from individuals that died in specific circumstances, mired in mud, trapped by drought near a water hole, caught by some rapid burial event. But when you see a titanosaur skeleton in a museum, even incomplete, the scale is humbling. These were real animals that walked the same earth we walk, under the same sun, drinking the same water, just separated from us by an almost unimaginable gulf of time. They were successful, thriving for millions of years. And then, like all dinosaurs except birds, they vanished in the great extinction that ended the Cretaceous period. Their time is over. But the fossils remain, testament to a time when giants walked the earth, when the largest land animals in history browsed across ancient Patagonia, living lives we can only glimpse through scattered bones and occasional trackways preserved in stone. For most of the 20th century, dinosaurs were depicted as scaly, reptilian monsters, essentially big, terrifying lizards. Then, in the 1990s and 2000s, discoveries in China revolutionized our understanding. In the Liaoning province, in fine-grained sediments from the Cretaceous period, paleontologists began finding dinosaur fossils with something unexpected: feathers. Not just primitive bristles or proto-feathers, actual feathers, preserved in exquisite detail, showing modern feather structure with shafts, barbs, and barbules. And these feathers weren't on bird-like dinosaurs. They were on dinosaurs of all types: small theropods, large tyrannosaurs, and even some ornithischians. Feathers, it seemed, were much more common among dinosaurs than anyone had imagined. Microraptor was one of the most spectacular discoveries. It was small, about the size of a crow, with 4 wings, large feathers not just on its arms but also on its legs. The feathers were preserved well enough that scientists could analyze their microscopic structure and determine they were iridescent black, like a crow or raven. Microraptor could glide and possibly fly, using its 4 wings to maneuver through the forests of Cretaceous China. Yutyrannus was even more surprising, a tyrannosaur relative, but covered in filamentous feathers. It was large, over 9 meters long and weighing over a ton, making it the largest feathered animal ever discovered. The feathers were probably for insulation in the relatively cool climate of early Cretaceous China. A giant feathered predator stalking through forests sounds like something from fantasy, but it was real. These discoveries forced paleontologists to reconsider everything about dinosaur appearance and behavior. If dinosaurs had feathers, What else was different from the scaly monsters of old illustrations? How many dinosaurs were feathered? What colors were they? How did they use their feathers? Modern birds are dinosaurs. Specifically, they're a lineage of theropod. Dinosaurs that survived the mass extinction and continued evolving. This isn't poetic language or a metaphor. Birds are literally dinosaurs, as much as bats are mammals or snakes are reptiles. The features that make birds distinctive, feathers, wings, beaks, wishbones, hollow bones, all evolved in non-avian dinosaurs first. Birds just happened to be the lineage that survived and diversified. This means the classic image of dinosaurs, scales, dull colors, lizard-like, is probably wrong for many species. Theropods especially were likely covered in feathers, possibly brightly colored, possibly with complex patterns. They may have used those feathers for display, for courtship, for species recognition, just as modern birds do. Velociraptor, made famous by movies, was almost certainly fully feathered. Not with the sparse quills shown in films, but covered in real feathers, giving it a bird-like appearance. It was also much smaller than depicted, about the size of a turkey rather than Saul, a human. The raptors in movies are actually based on Deinonychus, a larger relative, but even Deinonychus was probably feathered. This changes how we imagine these animals moving and behaving. Feathered dinosaurs couldn't have been sluggish, cold-blooded reptiles. Feathers require a lot of energy to maintain, suggesting active, warm-blooded metabolisms. These were energetic animals, possibly more like birds or mammals than like modern reptiles in their activity levels and behaviors. Some large dinosaurs probably had limited or no feathers. There's an upper size limit where feathers become a liability for temperature regulation, and elephants and rhinos are mostly hairless for the same reason. But smaller and medium-sized dinosaurs, especially theropods, were likely extensively feathered. The Chinese fossils preserve not just feathers, but also stomach contents, showing what dinosaurs ate. Gastroliths, stomach stones used to grind food, preserved in body cavities, skin impressions, showing scales on parts of the body where feathers weren't preserved. Melanosomes, pigment structures that allow scientists to determine feather colors. We know that Anchiornis, a small feathered dinosaur, was gray and black with reddish-brown feathered crests. Sinosauropteryx had a striped tail. Borealopelta, an armored dinosaur, had reddish-brown camouflage coloring on its back and lighter colors on its belly, suggesting it needed to hide from predators despite being heavily armored. The more we learn, the stranger and more wonderful dinosaurs become. They weren't slow, dim-witted reptiles. They were active, diverse, complex animals with feathers and colors and behaviors as sophisticated as any modern animal group. They built nests and cared for young. They communicated with vocalizations and visual displays. They formed social groups and engaged in complex behaviors. Imagine walking through a Cretaceous forest 120 million years ago in what is now China. The trees are conifers and ginkgos, not yet evolved into modern forms. And moving through those trees are creatures that look almost like birds, but not quite. Feathered theropods climbing branches, gliding between trees, hunting insects and small prey. Colors flash in the shadows. Iridescent blacks, reddish browns, patterns we can only partially reconstruct. Calls echo through the forest. Not quite bird songs, but not reptilian either. Something in between. This is the world the Chinese fossils reveal. Not a world of monsters, but a world of beauty and diversity. Of animals as colorful and active as any tropical rainforest today. Living complex lives under ancient skies, eventually becoming the birds that fill our world now. Tyrannosaurus rex lived at the very end of the age of dinosaurs, in the late Cretaceous period, about 66 million years ago. It was one of the largest predators ever to walk on land, up to 12 meters long, weighing perhaps 9 tons, with a skull over 1.5 meters long filled with teeth. the size of bananas. But T-Rex wasn't just big, it was sophisticated. Its skull was a marvel of engineering, massive but not solid, built with openings and air spaces that reduced weight while maintaining strength. The teeth were designed for crushing bone, not just slicing flesh. Bite force estimates suggest T-Rex could bite with over 12,000 pounds of force, enough to crush a car. Its vision was excellent, probably better than an eagle's. The eyes faced forward, providing binocular vision and depth perception, important for a predator. Its sense of smell was extraordinary, with a massive olfactory bulb suggesting it could detect scents from miles away. It could likely smell carrion from great distances, making it an efficient scavenger as well as a predator. Recent discoveries have revealed more about T-Rex biology. Some specimens show evidence of infections, healed injuries, and diseases. One famous specimen, Zeus, had marks on her jaw suggesting she suffered from a parasitic infection similar to trichomoniasis, which affects modern birds. She also had broken ribs that healed, a torn tendon, and other injuries showing the hard life of a large predator. Growth rates were rapid. Young T-Rex grew quickly, putting on several pounds per day during adolescence. They reached adult size in about 20 years, then stopped growing. This differs from the continuous growth seen in sauropods. T-Rex had a more mammal-like growth pattern, reaching maturity and maintaining that size. Juvenile T-Rex looked and behaved differently from adults. They were more lightly built, with relatively longer legs and narrower skulls. They probably hunted different prey than adults, filling a different ecological niche. This meant a single species, T-Rex, occupied multiple niches across its lifespan, reducing competition between age groups. Social behavior is debated. Some trackways suggest tyrannosaurs traveled in groups, at least occasionally. But whether these were family groups, hunting packs, or just coincidental gatherings at feeding sites is unknown. Modern large predators range from social, lions, to solitary, tigers, so either is plausible. What we do know is that T-Rex was the apex predator of its ecosystem. Nothing else in late Cretaceous North America could challenge a healthy adult. It fed on Triceratops, Edmontosaurus, and other large herbivores. Bite marks on their bones show T-Rex didn't just scavenge, it actively hunted and killed. The last T-Rex that ever lived died sometime around 66 million years ago, shortly before or during the mass extinction event that ended the dinosaurs. We don't know exactly how it died, whether it was killed by the immediate effects of the asteroid impact, or survived the impact only to die in the environmental catastrophe that followed. Imagine being that last T-Rex. The asteroid has struck the Yucatan Peninsula. The sky has darkened with dust and debris. Fires rage across the continent. The temperature is swinging wildly, first intensely hot from the impact's thermal pulse, then rapidly cooling as dust blocks the sun. Plants are dying. The herbivores you hunt are dying. Food is becoming scarce. You're hungry, but there's nothing to hunt. The herds of Triceratops and Edmontosaurus have vanished. You find carrion, animals killed by the fires or starvation, but it's not enough. You're cold, something you've never experienced before. The world is darker than it's ever been. And slowly, over days or weeks or months, you weaken. Eventually you die, the last of your kind, the end of a lineage that had dominated for millions of years. Or maybe you didn't survive that long. Maybe the impact's effects killed you quickly. The blast wave, the heat, the rain of debris, we don't know. What we do know is that T-Rex, along with all non-avian dinosaurs, disappeared from the fossil record at the Cretaceous-Paleocene boundary. They thrived for millions of years, survived climate changes and sea level fluctuations and countless other challenges, only to be wiped out by an asteroid strike that they had no way to predict or avoid. T's pre-Rex fossils are rare. Fewer than 50 partial skeletons have been found. This makes sense. Large predators are always rare compared to their prey. There needs to be a large population of herbivores to support even a small population of predators. And fossilization requires specific conditions that most dead animals don't experience. But each T-Rex fossil is a window into the life of an individual that lived 66 million years ago. Sue, the most complete T-Rex ever found, can be seen in the Field Museum in Chicago. Looking at that skeleton, the massive skull, the tiny arms, the powerful legs, you're seeing the actual bones of an animal that walked the earth millions of years before humans existed. Those bones supported flesh and muscle. That skull housed a brain that processed information, made decisions, reacted to its world. Sue was a living, breathing creature with daily struggles and needs and behaviors. And then she died, and by incredible chance, her bones were preserved, became fossilized, survived 66 million years of geological processes, eroded out of a hillside in South Dakota at just the right time to be discovered before weather destroyed them. The chain of unlikely events that preserved Sue and brought her to us is almost as remarkable as the animal herself. T-Rex reigned as king of its world for a few million years at the end of the Cretaceous. Then, that world ended and the reign was over. But the fossils remain, letting us glimpse the power and majesties of one of evolution's most successful predators, the tyrant lizard king that ruled and then vanished, leaving only bones to tell its story. 66 million years ago, on what seemed like an ordinary day in the late Cretaceous period, something appeared in the sky, an asteroid roughly 10 kilometers in diameter, traveling at speeds of tens of kilometers per second on a collision course with Earth. The dinosaurs, the pterosaurs, the marine reptiles, none of them knew what was coming. They couldn't. But in a matter of hours, their world would end. The asteroid struck the Yucatan Peninsula in what is now Mexico, hitting at an angle. The impact released energy equivalent to billions of nuclear bombs. The rock beneath the impact point vaporized. A crater over 150 kilometers wide formed almost instantly. Shockwaves propagated through the Earth's crust, triggering earthquakes far more powerful than any in recorded human history. The thermal pulse from the impact radiated outward at the speed of light. Everything within 1,000 kilometers was instantly incinerated. Further out, forests caught fire. Animals were burned alive or killed by the blast wave that followed seconds later. The sky itself seemed to ignite. Debris from the impact was thrown into the atmosphere. Pulverized rock, vaporized asteroid material, superheated steam. Some of this material reached escape velocity and left Earth's atmosphere entirely, only to rain back down hours later as the planet rotated. As this debris re-entered the atmosphere all around the globe, it heated the air to oven temperatures. The entire surface of the Earth was baked for hours. Animals that had survived the initial impact, that were far enough away to avoid the blast, died as the atmosphere itself became lethal. Tsunamis hundreds of meters high radiated from the impact point, sweeping across the Gulf of Mexico and the Atlantic, devastating coastal regions thousands of kilometers away. Inland, the shock waves and thermal pulse triggered wildfires that burned across continents. Then came the darkness. The dust and debris thrown into the atmosphere blocked the sun. Temperatures plummeted. Photosynthesis stopped. Plants died within weeks. Herbivores starved. Then carnivores starved as their prey disappeared. The food chain collapsed from the bottom up. This is called the Cretaceous-Paleocene extinction event, or the KPG extinction. It killed roughly 75% of all species on Earth. All non-avian dinosaurs died. All pterosaurs died. Most marine reptiles died. Many plant species went extinct. It was one of the worst mass extinctions in Earth's history. But not everything died. Small mammals survived, hiding in burrows, subsisting on seeds and insects. enduring the dark months or years until light returned. Birds survived. Small, flying dinosaurs that could cover large distances searching for food, that could eat seeds and carrion. Some reptiles and amphibians survived. Fish in deep water survived. Life persisted, diminished, but not destroyed. When the dust settled, literally, the world was transformed. The age of dinosaurs was over. The age of mammals was beginning. The survivors evolved rapidly, filling ecological niches left empty by the extinction. Within 10 million years, a blink in geological time, mammals had diversified into forms ranging from tiny shrews to large herbivores. By 50 million years after the extinction, the world looked nothing like it had during the Cretaceous. The asteroid impact wasn't the only stress on late Cretaceous ecosystems. Massive volcanic eruptions in what is now India, the Deccan Traps, were already affecting global climate. Sea levels were changing. Climate was shifting. The ecosystems were possibly already stressed when the asteroid struck, making recovery impossible. Some scientists argue the dinosaurs were declining before the impact, that they might have gone extinct eventually anyway. Others argue they were still thriving, that the fossil record shows diverse, healthy ecosystems right up to the boundary. The truth is difficult to determine because the fossil record is incomplete and biased towards certain environments and preservation conditions. What's certain is that the impact was catastrophic, and that dinosaurs, which had dominated for 160 million years, disappeared within a geologically brief time after it. Whether they would have survived without the impact is unknowable. What happened is that they didn't survive, and the world changed forever. Standing at the KP boundary today, the thin layer of rock that marks the extinction, you can see the evidence. In many places, there's a layer of clay enriched with iridium, an element rare on Earth's surface but common in asteroids. Below this layer, dinosaur fossils are abundant. Above it, none. The boundary is sharp, marking a moment when everything changed. Imagine the last day before the impact. Dinosaurs going about their lives unaware. A triceratops grazing on ferns. A T-Rex hunting across a floodplain. A herd of hadrosaurs migrating. Pterosaurs soaring overhead. The world thriving, complex, beautiful in its ancient way. And then, in the sky, something appears. A point of light growing brighter, larger, falling impossibly fast. For the creatures close enough to see it, there's perhaps a moment of confusion, of looking up at something they have no context for understanding. And then impact, and the end of their world. We know this happened because the evidence is clear. The crater, the iridium layer, the fossilized record of extinction. But knowing intellectually is different from imagining it emotionally. An entire world, with all its complexity and diversity, wiped out in a day. Species that had existed for millions of years, gone. Ecosystems that had taken millennia to develop, destroyed. And yet, life recovered. It always does. The planet has experienced multiple mass extinctions, each one devastating, each one followed by recovery and diversification. Life is resilient at the planetary scale, even if individual species are not. The dinosaurs died, but life continued, evolving into new forms, filling the empty world with new diversity. The descendants of the survivors surround us now. Birds are the last dinosaurs, the lineage that made it through the extinction and radiated into thousands of species. Mammals, our own lineage, survived as small creatures and then diversified to dominate terrestrial ecosystems. The world today is the world that extinction created, shaped by who survived and who didn't. Not all dinosaurs died in the extinction. One lineage survived, adapted, and thrived in the post-apocalyptic world. These were small theropods, likely already capable of powered flight, able to find food and shelter when larger animals couldn't. These were the ancestors of modern birds. Birds are dinosaurs. This isn't metaphorical or an interesting comparison. Birds are, by every biological and evolutionary measure, a group of theropod dinosaurs. They're as much dinosaurs as Velociraptor or T-Rex, just ones that happen to survive the extinction and continue evolving. The birds that survived the extinction were probably generalists, able to eat various foods, able to fly long distances, small enough to survive on limited resources. In the dark months, or years after the impact, when plants were dying and large animals were starving, these birds survived on seeds, carrion, insects, whatever they could find. As the world recovered and plant life returned, birds diversified rapidly. By 50 million years ago, most modern bird groups had already evolved. By 30 million years ago, birds had diversified into thousands of species, filling ecological niches from tiny hummingbirds to massive flightless predators. Some of these early birds were spectacular. Gastornis, once called Diatryma, lived in Europe and North America during the Paleocene and Eocene epochs. It stood over 2 meters tall, with a massive head and powerful beak. For years, it was thought to be a predator, a terror bird that hunted early mammals. Recent studies suggest it was probably herbivorous, using its powerful beak to crack tough seeds and fruits. The actual terror birds evolved in South America after it became isolated from other continents. Forest wrasses were large, flightless, predatory birds that dominated South American ecosystems for millions of years. The largest species stood 3 meters tall, with heads the size of horses. They were apex predators, filling the niche that large predatory mammals filled on other continents. In New Zealand, isolated from mammalian predators, birds evolved into incredible diversity. Moas were giant flightless herbivores, some species standing over 3 meters tall. They thrived for millions of years until humans arrived in New Zealand and hunted them to extinction within a few centuries. The elephant birds of Madagascar were possibly the largest birds ever to exist, standing over 3 meters tall and weighing up to half a ton. Their eggs were enormous, over 30 centimeters long, with volumes equivalent to over 100 chicken eggs. They too went extinct when humans reached Madagascar, unable to survive hunting pressure and habitat changes. But most bird evolution produced smaller, more familiar forms. Songbirds diversified into thousands of species. Parrots evolved intelligence rivaling primates. Owls became nocturnal hunters with silent flight and incredible hearing. Seabirds evolved to spend most of their lives at sea, coming to land only to breed. Today, there are roughly 10,000 bird species, making them more diverse than mammals. They occupy every environment from the Arctic to the Antarctic, from deserts to rainforests, from the open ocean to mountain peaks. They show incredible variety in size, behavior, and ecology. And they all trace back to the theropod dinosaurs that survived the extinction. Every robin, every eagle, every penguin, every ostrich. They're all dinosaurs, carrying the legacy of the Mesozoic into the modern world. Watching a bird, knowing its evolutionary history, changes how you see it. That crow picking at roadkill is a descendant of dinosaurs that survived the worst day in Earth's history. That hawk soaring overhead shares ancestors with Velociraptor. That chicken in a barnyard is more closely related to T-Rex than T-Rex was to Stegosaurus. The features that make birds distinctive evolved gradually over millions of years in their dinosaur ancestors. Feathers evolved long before flight, probably for insulation or display. Hollow bones evolved for weight reduction. The wishbone, the backward-pointing pubic bone, the three-fingered hand, all evolved in non-avian theropods. Flight itself evolved gradually. The dinosaur ancestors of birds were probably already climbing trees, gliding between branches. Natural selection favored those that could glide farther, maneuver better, eventually generating enough lift for powered flight. By the late Jurassic, about 150 million years ago, animals like Archaeopteryx were flying, or at least gliding, through ancient forests. These early flyers weren't modern birds. They had teeth, long bony tails, clawed wings. But they were on the path to becoming birds, evolving the features that would allow their descendants to survive when larger dinosaurs couldn't. The extinction was catastrophic, but it created opportunities. With large dinosaurs gone, birds could diversify into niches that had been occupied. Small mammals did the same. The extinction cleared the board, allowing survivors to radiate into new forms. So, when you see a bird, you're seeing a dinosaur. Not a relative of dinosaurs, not something descended from dinosaurs in some distant way, but an actual dinosaur, as legitimate as any T-Rex or Brachiosaurus. The age of dinosaurs didn't end 66 million years ago. It continues in every bird that flies, sings, nests, and raises young in the modern world. Dinosaurs didn't appear from nothing. They evolved from earlier reptiles in a world already ancient and full of life. To understand dinosaurs, we need to look back further, to the Permian and Triassic periods, when life on land was still relatively new and experimenting with different forms. The Permian period, from 299 to 252 million years ago, was dominated by synapsids, animals more closely related to mammals than to reptiles or dinosaurs. These weren't mammals yet. They were reptiles with some mammal-like features, slowly evolving toward the mammalian condition. Dimetrodon is the most famous Permian synapsid, often mistakenly called a dinosaur. It had a spectacular sail on its back, made of elongated vertebrae covered with skin. This sail may have been for temperature regulation or display. Dimetrodon was a predator, hunting across the supercontinent Pangaea, which had formed as all the world's landmasses collided together. The Permian ended with the worst mass extinction in Earth's history, the Permian Triassic extinction, or the Great Dying. Over 90% of all species went extinct, probably due to massive volcanic eruptions in Siberia that released enormous amounts of greenhouse gases, causing rapid climate change, ocean acidification, and oxygen depletion. The survivors evolved rapidly in the Triassic period that followed. Archosaurs, the group including dinosaurs, pterosaurs, and crocodilians, began diversifying. Early dinosaur relatives appeared, small and unremarkable compared to other animals of the time. The Triassic was dominated by other reptile groups. Phytosaurs looked like crocodiles and filled similar ecological niches. Etosaurs were heavily armored herbivores. Rauisuchians were large predators. Dicynodonts, surviving synapsids, were the dominant herbivores for much of the period. Dinosaurs were minor players in Triassic ecosystems, small animals living in the shadow of these other groups. But they had advantages that would eventually allow them to dominate. They walked upright with legs directly beneath their bodies, unlike the sprawling posture of other reptiles. This made them more efficient at moving, better able to run and maneuver. They had different hip structures that allowed for more flexibility and power. They had complex lungs with air sacs, similar to modern birds, allowing efficient oxygen extraction. These features gave them advantages that would become crucial after the next mass extinction. The Triassic-Jurassic extinction, about 201 million years ago, killed off many of the groups that had dominated the Triassic. The causes are debated, possibly another massive volcanic eruption, possibly asteroid impacts, possibly climate change. Whatever the cause, it cleared the way for dinosaurs. In the Jurassic period that followed, dinosaurs radiated into every terrestrial niche. Sauropods evolved gigantism. Theropods diversified into forms from tiny Compsognathus to massive Allosaurus. Ornithischians developed armor, horns, and elaborate display structures. The Jurassic and Cretaceous periods, spanning from 201 to 66 million years ago, were the age of dinosaurs. They dominated every continent, every terrestrial ecosystem. They evolved into thousands of species with incredible variety. They were successful beyond measure, thriving for over 130 million years. But they weren't the only success story. Mammals existed throughout the age of dinosaurs, small and nocturnal, occupying niches dinosaurs couldn't access. Crocodilians thrived in aquatic environments. Pterosaurs ruled the skies. Marine reptiles like plesiosaurs and mosasaurs dominated the oceans. The Mesozoic era, the age of dinosaurs, was a time of incredible diversity and evolutionary innovation. Life on land had existed for over 100 million years by the time dinosaurs appeared, and in that time, countless experiments in body plans and lifestyles had occurred. Dinosaurs were just one experiment, one that happened to be spectacularly successful for a very long time. Looking back before dinosaurs reminds us that they weren't inevitable. Life could have gone many different directions. If the Permian-Triassic extinction had killed different lineages, if the Triassic-Jurassic extinction hadn't happened, the world might have been dominated by entirely different creatures. Dinosaurs succeeded partly through their own adaptations and partly through luck, being the right animals in the right place when opportunities arose. And their success wasn't permanent. The asteroid that ended the Cretaceous proved that even the most successful lineages can be wiped out by events beyond their control. Dinosaurs ruled for over 160 million years, but in the end, a rock from space ended that reign. The only dinosaurs that survived were the ones that happened to have evolved flight, that happened to be small enough to survive on limited resources, that happened to be in the right place at the right time. Evolution isn't a progression toward better forms. It's adaptation to circumstances, and when circumstances change, previous adaptations can become irrelevant or even harmful. Dinosaurs were supremely adapted to Mesozoic conditions. When those conditions changed catastrophically, most couldn't adapt quickly enough. The age of dinosaurs ended not because they were failures, but because the world they were adapted to ceased to exist. Fossils are dead things that tell stories of life. A bone embedded in rock speaks of an animal that lived millions of years ago, that walked and ate and breathed and eventually died, its body buried in just the right conditions to preserve as stone rather than decay into nothing. The process of fossilization is rare. Most dead animals are eaten or decay completely. Only in specific circumstances, rapid burial in sediment, the right chemical conditions, millions of years of pressure and mineral replacement, do bones become fossils. For every fossil we find, millions of animals lived and died, leaving no trace. Paleontology is detective work with incomplete evidence. A single bone can tell us the size of an animal, roughly what it ate, how it moved. But it can't tell us color, behavior, social structure, the things that made the animal alive rather than just a skeleton. We infer these from context, from comparisons with living animals, from rare exceptional fossils that preserve more than just bone. Sometimes we get lucky. The Chinese fossils that preserve feathers, fossils with skin impressions, fossils with stomach contents showing last meals, trackways showing behavior, nesting sites showing reproduction, fossilized dung showing diet. Each discovery adds detail to our picture of prehistoric life. But most of what we'd like to know is unknowable. What sounds did dinosaurs make? We can guess based on skull structure and living relatives, but we can't know for sure. What colors were they? For a few species with preserved melanosomes, we have some idea. For most, we can only speculate. How did they interact socially? Some trackways suggest herding or group behavior, but details are lost to time. This uncertainty frustrates, but also fascinates. Dinosaurs are real animals that lived in real ecosystems, but they're also partially imaginary. We fill in gaps with educated guesses, with artistic interpretations, with inferences that might be right or might be completely wrong. Every few years, new discoveries change our understanding. Feathered dinosaurs overturned ideas about appearance. Studies of growth rates changed ideas about metabolism and life history. Analysis of bone chemistry revealed information about diet and migration. The science is constantly evolving as new fossils are found and new techniques are developed. What's remarkable is how much we do know despite the challenges. We know dinosaurs evolved from earlier reptiles in the Triassic. We know they diversified into thousands of species across 3 periods. We know some were massive herbivores and others were efficient predators. We know they built nests and cared for young. We know they had complex behaviors and social structures. We know they dominated for over 160 million years before being wiped out by an asteroid impact. This knowledge comes from thousands of fossils, studied by generations of paleontologists. Each fossil is a piece of the puzzle. Each discovery adds to our understanding. The picture will never be complete. Too much has been lost to time, but it becomes clearer with every find. The dinosaurs are gone, except for birds. Their world is gone, transformed by plate tectonics and climate change and millions of years of evolution. But the fossils remain, scattered across continents, buried in rock layers, waiting to be discovered. Some have been found and studied. Others remain buried, unknown. And some were destroyed by erosion or geological processes before anyone could find them. In museums around the world, dinosaur skeletons stand as testaments to deep time. These bones are incredibly old, older than human civilization, older than our species, older than our genus. They come from animals that lived in a world so different from ours that it's almost alien. Yet they're real. They existed. And through careful study, we can glimpse their world. As you drift toward sleep, imagine those ancient landscapes. Forests of conifers and ferns, plains where herds of hadrosaurs grazed, coastlines where pterosaurs soared, and everywhere dinosaurs, living, breathing, moving creatures going about their lives unaware that they would someday be gone, that their bones would become stone, that creatures unimaginably different would find those stones and wonder at their size and shape and the lives they represented. The fossils sleep in stone, waiting. Some will be found tomorrow, next year, next century. Others will erode away before anyone discovers them. And others will remain buried forever, their stories untold, their lives unknown except to the rock that holds them. But the ones we've found tell us enough. They tell us the earth is ancient beyond human comprehension. They tell us life has taken countless forms over billions of years. They tell us that success is temporary, that even the mightiest creatures can be wiped out. By chance events, that survival often comes down to luck as much as adaptation. And they tell us that life persists. After every extinction, survivors remain. They evolve, diversify, fill the empty world with new forms. The story of life on Earth is one of constant change, of species appearing and disappearing, of ecosystems rising and falling, but life itself continuing, adapting, enduring. The dinosaurs had their time. It was long and glorious, a reign that lasted longer than most animal groups ever achieve. Then it ended, suddenly and catastrophically, and the world moved on. But they're not forgotten. The fossils remain, telling their story to anyone willing to listen, to anyone who looks at ancient bones and sees not just stone, but the echoes of life from deep time. Sleep now and dream of ancient worlds, of creatures long extinct, of forests that no longer exist, and skies that look different from ours. Dream of a time when dinosaurs walked the earth, when life took forms we can barely imagine, when our planet was young and anything seemed possible. The fossils sleep in stone, and in our dreams, they wake and walk again, alive once more in the theater of imagination, roaring and flying and swimming through landscapes lost to time but not to memory. The age of dinosaurs is over, but their story continues, told in fossils and reconstructions, in scientific papers and museum displays, in the endless human fascination with these ancient giants. They lived, they thrived, they died, and they left behind enough traces for us to glimpse their world and wonder at its strangeness and beauty. Rest well, knowing that the earth has seen wonders beyond counting, that time is deep and life is old, that we're part of a story billions of years in the making, a story that includes trilobites and dinosaurs, mammoths and humans, all the countless species that have lived and died on this ancient planet spinning through the void. The dinosaurs sleep in stone, and in our dreams, they live again.